problems don't start with an inverse. So if I don't give you an inverse, we are talking about every time something happens. So let's say I ask you to solve this equation. We're going to give two different answers, but we're starting with 3 tangent of theta minus radical 3 equals 0. If I asked you to solve that for tangent, what would you do? And then we would divide by 2. Okay. This is different than yesterday because does this say tangent inverse here? No. So I'm dealing with all 4 quadrants on the circle. I want tangent to be positive, so I need to know every time tangent is positive. When is tangent positive? Which quadrants? Okay. We are in degrees, so I need to know part A, every time between 0 and 360. What is my reference angle? When does tangent equal radical 3 over 3?
Wait, what?
When is tangent equal to radical 3 over 3?
Probably never. No, wait, not it.
That's it. Our hand tricks, so tangent is 0.
Oh, because it's 6.
It's 30, because that would be radical 1 over radical 3, which turns into radical 3 over 3.
Yeah.
Okay. So tangent of 30 is radical 3 over 3. So, my answer. In quadrant 1, 30 degrees is 30 degrees. In quadrant 3, if your reference angle is 30, what's the actual angle? 210, 180 plus 30. So that's my answer. So A was just asking between 0 and 360, when does this happen? It happens twice. At 30 degrees and 210 degrees. B, I want all solutions every single time. Now we know every time we go around the circle, you hit it again, right? So it happens at 30, and then it would happen again at 390, and every time we go around, right? All the way around the circle is how far? 360. So if I say all solutions, you just have to take each of those answers we got and say plus 360 degrees K. We do that for both answers. The 360, that's all the way around the circle. K here is an integer. So it's just some multiple of 360. 1, 2, 3, negative 1, negative 2, negative 3. That would give me every possible solution. So when I say all possible solutions, you have that K in there. Questions right there.
Wait, how? I thought we weren't supposed to use quadrant 3.
That's when we have an inverse. This didn't have tangent inverse, it was just regular tangent.
So how did we know that it was quadrant 3? Because
We're looking at all students take calculus. So tangent was equal to a positive,
yeah.
so that's in 1 and 3. Okay. If it had been tangent inverse, then it would have just been the answer in quadrant 1. Other questions? Let's try another one. So what would I do here? 2 sine theta plus 1 equals 0. So sine is equal to negative 1/2. So sine is a negative. When is sine negative? Mhm. Reference angle. When is sine 1/2? 30 degrees. So my answer to part A, every answer between 0 and 360. 30 degrees in quadrant 3, so 180 plus 30 is 210. In quadrant 4, you do 360 minus 30, which is 330. B. If I say all solutions, what do you have to do?
Plus 360.
Mm-hmm. So you take each answer we got plus 360 degrees K. Because that's how far it takes to get all the way around the circle. We should specify that K is an integer. The shorthand for that is K, this little curved E, and then the integer bar, or the integer symbol is a Z with a double bar. I don't care if you write it in symbols or if you say in words K is an integer, but you should be specifying that, because we can't do, 360 times a half wouldn't take us all the way around the circle. So we have to make sure we're going all the way around, so we can only do integer values. All right. Questions there? Let's do another. So this one, I am only asking from the interval 0 to 360. So that means we don't have to do the plus 360K. We're just giving the original answers the first time around the circle. This one is a little bit different because I have multiple trig functions. So we're going to have to use a different strategy to solve this equation. If I gave you something like, let's say 2x squared equals negative x. What would you do to solve that? But we have x is in both of them, don't we? Yeah, we would bring the x over and then we could factor out the greatest common factor. So that's what we're going to do here. So we're going to bring over that cosine theta. So now I have two terms. What do they both have? Cosines. We take out the cosine theta. Now, if you have two things multiplied that equal 0, that means one of those has to be 0, right? So either cosine equals 0 or cotangent theta plus 1 equals 0. So we have to solve each of these. When is cosine 0? So if you think about your unit circle, cosine is x. When is x 0?
90 to 70.
Mm-hmm. So those two answers came from this part. All right. This one, this means cotangent equals negative 1. When is cotangent negative? Reference angle. If cotangent is 1, that means tangent is 1. When is tangent equal to 1? Mm-hmm. Okay. So the answers for this part, 45 degrees in quadrant 2, mm-hmm, and 45 degrees in quadrant 4. So these came from that part, but all 4 of those are my final answer. That means if I took any 4 of those values and plugged them into the original equation, it would work. You could grab your calculator and try it if you wanted. They would all turn out to be equal. Questions on that? Should we try one more and then stop for the day? I'm not going to give you any more homework. We only have the homework from yesterday that's due tomorrow. Tomorrow we will do more of these examples, but we'll just get through a few of them today. So last example for today. You cannot just divide by sine theta because you will lose answers when you do that. So never divide by a variable. Instead, what do we do? Then what could we do? Factor out the sign. And then what do we do?
7 0.
Okay, so my answers. When is sine 0? If you think about your unit circle, sine is the y. When is y 0?
0
This one. If I solve it, it says tangent would be equal to positive 1. In which quadrants is tangent positive?
3.
Reference angle. When does tangent equal 1?
45.
Okay, so 45 degrees in quadrant 1 is
45.
45 degrees. In quadrant 3, 180 plus 45 is 225.